Suppose a stone is thrown vertically upward from the edge of a cliff on Earth with initial velocity 64 feet per second from a height of 32 feet above the ground. The height in feet of the stone above the ground t seconds after it's thrown is this. So this is going to be the position function, which will give the height of the function up and down. Okay, so I sketched out a preliminary graph. It started at 32 feet, so that's somewhere between 25 and 50. Okay, and it goes up. The graph or the rock is getting thrown up, and after time passes, it goes up, up, up until it hits its maximum value somewhere, and then it stops for a moment, and then it starts coming back down with a negative velocity. So positive velocity going up, negative velocity coming down. Okay, and it hits its maximum somewhere in here, and we'll figure that out. Okay, determine the velocity v of the stone after t seconds. So velocity is the derivative of the position function. So it's going to be v of t. Okay, so we take the derivative of this. Okay, so we bring down the 2, make it negative 32t. The derivative of this is just 64. The derivative of 32 goes away, so that is a. That's the derivative of that function, which is the velocity. Okay. Next question: when does the stone reach its highest point? So here, the stone reaches its highest point. Remember, it gets thrown up, goes up, 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 stops, and starts coming back down. So we are looking for this point where the velocity is 0, or this line is flat. It's got a 0 tangent line here. So we're looking for where v of t is equal to 0. So we're going to set negative 32t plus 64 equal to 0. Now, if I move that 64 over, I'd get negative 32t equals negative 64. And then if I divide by the negative 32, I get t is equal to 2 seconds. Okay, so after 2 seconds, it reaches its maximum height, stops, and starts coming back down. Okay, next question: what is the height of the stone at the highest point? Okay, so we know where the highest point occurred by setting the velocity equal to 0. The highest point occurs in 2 seconds, but where is it? We have to go back to the position function, plug that in. So we're going to plug in 2 into s, so s of 2 is equal to negative 16 times 2 squared plus 64 times 2 plus 32. Okay, and if you work that all out, you will get 96 feet. So its maximum height is 96 feet. Okay, D, when does the stone strike the ground? Okay, so it strikes the ground over here, right? Over here, we don't care about this one over here because that's before everything happened. Okay, so the stone strikes the ground somewhere over here. We need to figure that where that is by setting the position function equal to 0. 0 because it's on the ground. So we need to set s of t equal to 0 and solve, which means I get negative 16 t squared plus 64t plus 32. Set that equal to 0. I'm going to divide everything by negative 16. And when you divide the 0 by negative 16, it does not change. So that becomes t squared minus 4t minus 2 equals 0. Now, you can try to factor that, but it is not factorable. So we're going to need the quadratic formula, which I'll write here. T is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and our a on this one is the number in front here, which is a 1. B is the number in front of t, which is a negative 4. And then c is this last number, negative 2. Okay, so let's go over here and figure out what that's going to give us. Put it over here. So t is equal to negative b, so negative 4, so that's positive, plus or minus the square root of negative 4 squared, b squared, minus 4 times a, which is 1, times c, which is negative 2, all over 2a. Excuse me, I should have plugged in that 2 times 1. Okay, so if we clean up the inside of that, we get 4 plus or minus the square root of 24 over 2. Okay, you can clean up this, you can clean up that square root there as well. That 24 will become it will become 2 square roots of 6. So 4 plus or minus 2 square roots of 6 over 2. And now I can divide these two separately by the 2. So I get t is equal to 2, that's 4 divided by 2, plus or minus, and then this 2 cancels, leaving a square root of 6. Okay, so we're looking for which one of those is positive, because looking at the graph, we don't care about the part of the parabola that came over here. We only look at this. So you can see that the minus case, 2 minus square root of 6 would give me a negative answer, which I don't want. So I'm going to use the positive answer. So I'm going to say this one is t equals 2 plus square root of 6. And if you want an estimated answer, that's going to be 4.45, and this is seconds. Okay, so this is the exact answer and the estimated answer. Okay, let's look at E. With what velocity does the stone strike the ground? So we know it strikes the ground at 4.45 seconds, which is this. So I just plug this into the velocity like I did that other one earlier. So E, V of 2 plus square roots of 6. Okay, and think about what this is going to be. It's the velocity when it hits the ground. Velocity is going up here. The velocity is going down here. So it'll be negative velocity. Let's make sure that we get that answer. So negative 32 is the velocity function. I'm going to plug in 2 plus square root of 6. Okay, and then plus 64. Okay, so distribute that negative 32. So that's negative 64 for the first one, and then minus 32 square roots of 6, and then plus 64. So the 64s will cancel there, and we will get negative 32 square roots of 6 is my exact answer. And it's negative, which is good. And if we put that into the calculator, our estimated answer would be negative 78.38, and that's feet per second. So this is the estimated, rounded to 2 decimal places, and this is, oh, you can't see. This is the estimated, and this is the actual answer. All right, last one. F, on what intervals is the speed increasing? Okay, so this one is kind of when we have to think about a minute. Think about gravity. Gravity is always pulling stuff down, right? Pulling stuff down. So gravity for us is always negative. So if the speed is increasing, then velocity and gravity have to be the same. So here, the speed is decreasing because gravity is working against it. But then when it hits this point and starts going down, gravity is working with it to increase its speed. So the velocity and acceleration are both negative, which means it is increasing in speed. Okay, so if that's the case, when both velocity and acceleration are the same sign, then you have positive speed. So in what intervals is it increasing? Well, from that highest point, which we found was 2 seconds, from 2 is less than t is less than, and that last point over here was the 4.45, or the 2 plus square roots of 6. And there's that answer. And if you wanted to write it in interval notation instead of set notation, it would be all the numbers between 2 and 2 plus square root of 6. And that is it for that problem.